Now notice in these next set of examples it says use the properties of logarithms to rewrite each expression as a single logarithm. So what does that mean? We're going to be taking multiple logs and bringing them together. Remember that we can only bring logs together if they have the same base. So let's look at problem A. Well, we have a log base b of k minus a log base b of m minus another log base b of a. So what's important is all of these logs do match up. They all have the same base. They all have log base b. Now, what we're going to have first is our k. Now, we know that the other two pieces are going to be on a denominator because there is a minus sign in front of those. So they'll be underneath or divided by. Well, what are those two pieces we're going to be dividing by? Well, that's your m and your a because they both have minus signs out in front. So we have log base b of k over ma. Now, if you really wanted to, you could put parentheses around the k over ma, but you don't have to. You can leave it just like this. Okay, let's look at problem B. On problem B, what types of logs do we have? We have a log base a on our first piece and a log base a on our second piece. So when we put these together, we're going to have a log base a of some kind. Now, before we do anything, though, we can't bring the two logs together until we just have the logs there. So I need to deal with what is out in front of that first log, the 2. Well, remember things get moved out in front if there's exponents, so if we want to bring it back in, it's going to come in as an exponent, which means I actually have a z minus 1 squared there. Okay, well, now I can bring together these two pieces that I have, the z minus 1 squared and the 3z plus 2. Remember, before we broke up multiplication with a plus, we're doing the reverse. We're taking the plus that's already broken up and bringing them back as multiplication. So we'll have that z minus 1 that we had that was squared, but in order to bring these together, we're going to lose the addition and turn it into multiplication times the other piece, the 3z plus 2. In this last piece here, just to kind of point this out, the z is greater than 1 is there, but it really doesn't affect our problem in any way whatsoever. So this is just our final answer. Log base a of z minus 1 squared times 3z plus 2. And remember that the parentheses already mean multiplication, so you don't really have to write that dot in the middle for multiplication. Let's look at problem C. Notice again we do have two log base b's, so when we put this all together we'll end up with another log base b. Now, let's see, what's going to come first is whatever we see first, which is the 2y plus 5. So let's go ahead and rewrite that. Now the minus here tells us, this minus here tells us that whatever comes next is going to go on the denominator of the 2y plus 5, or on the bottom of a fraction. What's going to go on there is it's going to have to deal with two parts. We have to deal with this 1/2 first that's out in front of our last log. Remember, numbers out in front got moved out in front because they were exponents. So if we want to bring it back in, it's got to come in as an exponent of 1/2. So that can be moved to the denominator because of the minus. When it comes in, it's going to be a y plus 3 on the denominator. Problem. I don't want to leave it as a 1/2 power. How can I rewrite a 1/2 power? Remember, the denominator can be telling you also that you can rewrite this as a root. That 2 on the bottom tells you that you can rewrite this as a square root. So we can rewrite this as log base b of 2y plus 5 over the square root of y plus 3. I do know that we generally don't like square roots on the denominator, but they didn't ask us to rationalize. They just said to rewrite it as a single logarithm, so we're just going to leave it as is. So our final answer is log base b of 2y plus 5 over the square root of y plus 3. In problem D, let's see what we've got. We've got the same log base for all of our logs. They're all ln's, which means they're all log base e. So when we bring them all together, it'll be, again, an ln, which means it'll all be a log base e. Now notice the first piece you see is the a plus b. So we can go ahead and put that inside. Now the plus in the middle of that and the a tell us that we're going to be multiplying the a plus b and the a. Well, we already have parentheses around the a plus b, so if I multiply it by an a, I don't have to write the multiplication symbol. You can, but you don't have to. Now the last piece, notice we see a subtraction sign, which means that whatever comes next is going to go on the bottom. What do we have here? Well, on this last piece, notice that we have a 1/2 out in front. Well, remember that's going to get moved in as an exponent, and so that will turn into 4 to the 1/2 power. Well, remember the 2 on the bottom tells you you can rewrite a 1/2 power as a square root. So this will be the square root of 4. Well, what's the square root of 4? It's just a 2. So what ends up going on the bottom is just that 2. So our final answer is the natural log of the a plus b times the a on top over what we got for the square root of 4, which was 2. The last thing that we're